What is going on here? Why doesn't this just happen? How does the ping pong ball just precariously float on a stream of air? Welcome to On the Shoulders of Science. If this is your first time here and you want to learn about some awesome scientific facts and concepts in a fun, easy to understand way, start now by subscribing and clicking the bell so you don't miss anything. So here's the thing, when a hairdryer or a human blows on a ping pong ball, it creates a kind of stream of air that engulfs the ball. But that still doesn't explain why the ping pong ball doesn't just easily fall off from that one stable position. Shouldn't this be like trying to balance a pencil on its point? Even if you could get it to balance, it would be very unstable, falling over at the slightest displacement. Now, the reason has to do with something called Bernoulli's principle, a somewhat counterintuitive concept that says that the pressure of a fast-moving fluid is lower than that of a stationary one. Oh, and air counts as a fluid, because it flows. It's fluid. Now, this is because when a fluid is stationary, the molecules are buzzing around in all directions, applying pressure randomly and uniformly. But when the fluid starts moving in an organized stream, the majority of each molecule's velocity is in the linear direction of travel, not outwards. So this means less pressure where the fluid is moving quickly. So what this means is that when you blow a fast stream of air around the ping pong ball, it creates an area of lower pressure around the ball. And the air around it, because it's been unaffected, therefore has a slightly higher pressure. So that creates a force, higher pressure air moving towards the lower pressure on all sides of the ball. So the ball is supported in every direction, meaning it's stable. Now, it's worth noting that this animation isn't entirely accurate. In reality, these flowing air molecules interact with the more stationary air over here, dragging the blue molecules up with them, so that more air from the sides comes to fill the empty space, helping to keep that airflow pressure supporting the ball. Okay, now back to the video. You can even move the hairdryer to the side and the ball will stay suspended, because Bernoulli's principle says the low pressure, high pressure gradient gives it enough stability. As long as the upward component of force of airflow is enough to counteract gravity, the ball will float. Bernoulli's principle is a really interesting phenomenon that occurs in a bunch of different real-world applications. From how planes fly, to the motion of parallel boats, how sailboats sail, how spinning balls curve, why you shouldn't stand next to a fast train, how roofs are easily blown away in heavy storms, and why ping pong balls float above a hairdryer. If you want to see more cool science stuff like this, make sure to subscribe if you haven't already. And if you like this video, you might also like another video on this mysterious effect you can observe on your own stovetop, called the Leidenfrost effect. Thank you for watching, I hope you learned something, and I'll see you next time.